how does the air pressure relate to the weight of air above us? So here on the surface of the Earth, we know that there is air pressure. It's about 14.7 psi, so in pounds per square inch. We saw before that that's about 101-ish kilopascal. So that's over 100,000 newtons per meter squared. But why does that air pressure really need to be there? And what this is suggesting by asking about the weight of the air is that pressure is really there because above us there's a lot of air going upward. So we're really supporting the full weight of that air. So let's check out the answer, because I have some slides here that are going to look at this. So if you imagine that we have a column of air, so air pressure near the surface of Earth relates to the weight of air in a column going upward. So there's this column, which is kind of drawn in a cartoonish fashion, but it's meant to be sort of an equal cross-section column throughout. Maybe use your imagination if it doesn't look like that, right? We can analyze it with a free body diagram, as with many systems, right? So even though it's just a column of air, we can represent it with a point, like in any FBD. Gravity, of course, is going to pull down on that. And the gravity force has a magnitude that is really equal to the weight of all the air in the column. So maybe if I write some of this over here, right? So the FBD we're starting with, right? Here it is. But it says weight of air there. Maybe I could write that as mg, where this m is really the mass of all the air in that column. The column of air must have a force to balance gravity, since the column is modeled as an object at rest, like a book on a table. Now, if this were a book on a table, we'd probably say that that upward force is a normal force. Whether that's really the appropriate description, maybe it could be. But maybe it's really one of those pressure forces, right? So it's, or really a reaction force to pressure. We don't normally, I think, label like, forces on a gas as normal forces, right? We usually restrict that, I guess, to solid objects. I guess one could make an exception, though. But the force up is essentially the force applied up on the air at the bottom of the column. It is the reaction force of the pressure the air exerts at the surface of the Earth, right? So let me put that in my diagram that I'm making over here. So it's a reaction force, but all reaction forces are equal to the force that is applied. And we know that a pressure force is equal to pressure times area, right? So that's what it says. The force is due to air pressure is equal to pressure times area. Since the force is balanced, the air pressure at Earth's surface equals the weight of the air column divided by the area at its bottom. So what is that really saying there? So if I think about this force as being pressure times area, and then I look at force balance, I have pressure times area is equal to weight, right? Because these forces must be equal to each other if they balance. So that means that if I solve for pressure, it would be weight divided by area, which really means it's the full weight of that column of air divided by the cross-sectional area of that air column.